Well, hello students and seekers of general truths. In this video, we will work on how to program your calculator to do certain tasks that are repetitive and perhaps tedious that you can sort of outsource to your calculator. But before we do that, let us begin with a brief refresher here on quadratics and particularly the quadratic formula. So if we have a function f of x is equal to ax squared plus bx plus c, then we know that the x-intercepts will occur at the opposite of b plus or minus square root b squared minus 4ac, all of this over 2a. Okay? So for example, if we have a graph like so, and let's say here's our graph, then one of the x-intercepts is going to be over here and the other one would be over here, and these x-intercepts will be produced by this particular equation. Now, so every time that you have a problem and you're asked to find the x-intercepts, we can use this formula. And now we can take that and extend the idea to something even more powerful, which is how do we make our calculators do that for us repeatedly. So the way we're going to do this is to write a calculator program. So on your calculator, find the program button and click on that. And notice here there are three options: execute, edit, and new. So I'm going to slide over to where it says new, create new. And I'm going to type in the name. Now the name has to be 8 characters or less, and it can only be letters, so there can't be any numbers or anything like that. So I'm going to call this quad, Q-U-A-D. Okay. And then if you notice here, the quadratic formula takes in 3 inputs, A, B, and C, and it produces 2 outputs. So that's what we're going to do here as well. We're going to prompt. So if you, now that we're writing the program, if we hit the program button, we get this new menu that shows up. Scroll over to where it says IO, which is shorthand for input output, and we're going to say prompt. Okay, we're going to prompt for A, and we're going to do this 2 more times. We're going to prompt for B, and then we're going to prompt 1 more time, and that'll give us the letter C. Okay. So now that we have these 3 variables, we can substitute them into the quadratic formula, which is opposite of B. And before I do that, make sure I have parentheses here. Opposite of B plus the square root of B squared minus 4AC, all of that over 2a. Okay. And I'm going to take these this result here and store it in a variable. So I'm going to store it in, say, the letter x. Okay. So x has the result of negative b plus square root b squared minus 4ac, all of that over 2a. And then I'm going to repeat the exact same thing, but we're going to do this for the minus. So opposite of b, opposite of b minus the square root of b, whoa, sorry about that. I clicked the wrong thing. All right, there we go. Back into it. Opposite b minus the square root of b squared minus 4ac, all of this over 2a. And we'll store it in another variable, which we can say is y. Okay. So x contains one result of the quadratic formula, and y contains the other. And then I'm going to print out this information. So we can see here, hit the program button, go to I/O where it says display X, and then one more line, program display Y. Okay. And then make sure you have a blank line at the end of your program. Okay. Now we hit second quit, and we exit out. And now we hit program one more time. This time, instead of going to new, we're going to stay on the execute option and run the quadratic formula program. So it's going to ask us for A. Now let's try some numbers. -16. B here would be 95. And these are just numbers that I'm picking here to test it out. And then 3 would be C. Okay. So we get these two numbers, negative 0.0314 and 5.9689. These are the x-intercepts. So in our example, if I were to say, you know, that f of x was equal to -16x squared plus 95x plus 3, then the quadratic formula would tell me that my two x-intercepts then would be about, and this is not drawn to scale, -0.03 and about 5.96. Okay, so that's what this program tells us, right? And it's a very nice program. If it works, then we can continue to use this all the time. Now I'm going to extend on this idea a little bit further. If you notice here that once I get the two x-intercepts here, the point in the middle, we'll call that H, this location here, that's the location of the vertex. So if I want to find H, all I have to do is average the left side and the right side of the two x-intercepts, and that will tell me the point where the vertex occurs, which is the max or the min. Okay, so H is equal to the average of these two numbers. Now if we go back to our program, well, what are those two numbers? To program, go to edit. Okay. Now let's go down to the bottom here, right? The two numbers that we calculated were x and y. So if we want to find the maximum point, right, then we can do this. We can say x plus y. So it's the average, right? It's in between those two divided by 2. Okay? And then we're going to store this into a new variable. We'll call it h. Okay, so h is the x-coordinate of the highest or the lowest point on a parabola. But that only gives us the x-coordinate. If we want to find the y-coordinate, then what we have to do is take h and plug it back into this equation. So plug it back into here, which is ax squared plus bx plus c. Now in our program, we can leverage this fact, and we can say that we're plugging h into the quadratic equation, not the quadratic formula, but the function. So it's going to be a h squared, because h is the value of the x-coordinate that we're looking for, plus b h plus c. Okay, and we're going to store this into a new variable. Let's call it k. Okay, so there we have it. We have an x-coordinate and a y-coordinate of the highest point. And we're going to display this. And this time, though, I'm going to give myself a little bit of a message so that I can see what this means. So if I hit second and alpha, this will lock everything into the letter alpha mode. And we'll say, quote, vertex, right? That high point or that low point is actually called the vertex. Space is, end the quote. And then a new line, we'll display h and we'll display k. Okay. So not only will this program give us the x-intercepts, exit out, let's run it again, and this program now will also give us the high point or the low point, depending how the parabola is shaped. Okay, so we know that these are the x-intercepts. This is the x-coordinate and the y-coordinate of the vertex. So back in here, in our example, now we know that this high point right here is about 2.969 and 144. Approximately. Okay. Now the purpose of this lesson, this video, is not for you to understand the quadratic formula, although it's good if this is a refresher for you. The point is for you to understand how to write calculator programs. Okay, so with these particular syntaxes, and at least on the TI 8384, you should be able to write a calculator program to do any sort of operation that is repetitive and that you have figured out will always work. Okay, so for example, I know the quadratic formula, I know this is the formula, this is how I calculate the x-intercepts, this is how I calculate the vertex. And rather than doing it manually every single time, I can just have a program do all of these steps for me. Okay. A word of advice is that whenever you write a program, you always want to check it with a problem that you've already worked on and that you know the answer is correct, just to make sure that the program does the thing that you expect it to do. As always, ask for help if you need it. Thank you for watching and have a wonderful day.